Welcome to the Real Turf Techs podcast for the technician that wants to get real. Follow along as we talk to industry professionals and address hot topics that we all face. Along the way, we'll learn tips and tricks. I'm your host, Trent Manning. Let's have some fun. Welcome to the Real Turf Techs podcast, episode 126. Today we're talking to Jerry Goman, Senior Principal Design Engineer at the Toro Company that just recently retired. Jerry served 2 tours of the Toro Company for a total of 39 years. He started in March of '83 and retired in March of 2024 with a 2-year leave of absence. Jerry worked on many product lines during his tenure at Toro, but spent a lot of time on greens mowers. Let's talk to Jerry. Welcome, Jerry, to the Real Turf Techs podcast. How you doing today, Jerry?
Just fine. Thank you, Trent. It's nice to be here. So.
Yes, sir. Thank you so much for joining us here, and I'm really excited to hear your story. So, okay. Tell us how you got to the Toro Company.
Well, I started at Toro probably like a lot of people start at most jobs, and that I graduated from college, had a dual engineering degree, one in agricultural engineering, one mechanical engineering. And I happened to be lucky at the time when I graduated, there was a glut of engineers. They didn't need anybody. So I had filled out paperwork to go on to grad school, to go into a mechanical engineering graduate program. And a friend of my dad worked at Toro in Tomah, Wisconsin, and said that they were just looking at starting to hire again. This was shortly after Toro had their financial woes and they had just started to open up again. And so I went and interviewed at Tomah, which was a manufacturing facility, which is only about 35 miles from where I grew up.
Oh, that's awesome.
And so it was kind of just down the road, if you will. And I went and interviewed and I got hired. And I was the first person to be hired at Toro and Tomah after they had like I said, the financial setback. So I was happy to get into the door, and my title at that particular point was I was a quality manufacturing engineer. So I did quality work and for the manufacturing facility.
Okay.
And not an auspicious start of looking specifically at Toro. It was an available job. I was fortunate from the standpoint with my degrees. I had originally planned to go into the ag industry and design ag equipment, farm equipment of some sort. Come to find out that the equipment that Toro does is a close cousin.
Yes, it is.
And so it worked out quite well for me. And the advantage of working at Tomah to start is, I could bring my knowledge from the farm, grew up on a dairy farm and dairy and beef. And so I had all that ability. It's one of those things where working in the field, you figured out how to get the unit running with a screwdriver and a pair of pliers, or you're walking home. So
right.
I kind of have that, innate ability, and started at the plant and was involved in a lot of problem solving and got to see the manufacturing side of it. And when I started, Tomah was building everything from cordless electric battery powered trimmers up through the HTM hydraulic transport mower. And so it was a huge range of equipment. We built snow blowers, rear engine riders. We built GM 72s. We were building Greensmasters, Sand Pros, Super Pros, if anyone remembers any of those, 70 Pros. From a walk greens mower standpoint, we were building both Series 4 and Series 5 Greensmasters. The Series 5 changed over into the Greensmaster 105. So a lot of history there, saw a lot of equipment, spent a lot of time on the floor, spent a lot of time in welding to try and understand how the fixtures work and that sort of thing. So I spent 7 years at Tomah and felt that I kind of wanted to change. And there was a design position that we were interviewing for at Bloomington in Minnesota at the corporate headquarters. So I went up and interviewed for that and got hired. That was about 1990 when I transferred up to Lindale.
Okay.
And my product responsibility at that point in time was the old Real Master 335. It had
Okay.
just been introduced, and it was the rough mower, et cetera, and so forth, and it needed some work. So I got into it feet first on working on some issues on the pump and some other issues and this sort of thing, and trying to resolve some issues in the cutting units. So it was kind of my first foray with cutting units and off tempering and those sorts of things in terms of the heat treatments and other things. And was then transferred, not really transferred, but the group I was working with got assigned a new product. So rather than me doing product maintenance, I was involved in a new product design, which was the 455D.
Okay.
455 was to take the 335 tractor and convert it to a rotary. And we were on an extremely short timeline. There was a number of things that I wanted to change that I was told we didn't have time. So
Mm-hmm.
there was some frustration on my part in that there was a lot of things that were within our grasp to fix in my mind, but we weren't given time to do that. When that product was completed, the product group was kind of disseminated, and I basically transferred over to greens mowers
Okay.
and started working on greens mowers. And I had product responsibility for the current products at that time would have been the GR300 and the first diesel units of this sort of thing was converted to the 3000, of course, as it changed through there. And the first product, the new product that I worked on there, along with the product responsibility, was the 3200.
Okay. Yep.
And working on the 3200, it was my section of it was the suspension, cutting unit suspension, and cutting units.
Okay.
So that was the first time I did a full new sheet, clean sheet design of the cutting units. And I was fortunate enough to talk to a lot of people who, when I got up on green boards, there was a lot of history, people that were there for a number of years. And so I did my darndest to pick their brain and say, what's the right thing? What do we need to do? And a gentleman that had been working on Greensmore cutting units, the old single point adjustment and 4-bolt cutting units that went way back.
Mm-hmm.
His comment to me was, whatever you do, make the overall construction stiffer, make them more robust.
Okay. Yep.
So when we went in and did the 3200 cutting unit, we did that. We made the bed bar pivots larger. We made the reel shaft tubular and larger diameter with hollow so that the overall weight of the reel went down, but the stiffness to bending and torsion went up just because you had a larger section. And the bed bars were heavier. We made everything a little heavier. That unit was still a single point adjustment. But up to that point, we had always had problems with single point adjustments prone to rifling. I'm assuming your group is familiar with rifling.
Yes. Yep. Or well,
Unfortunately,
I don't let's just in case. Let's describe that a little bit for the listeners. What is
yeah.
raffling?
Well, rifling, the way we define it from an engineering standpoint, is when the cutting unit goes into a vibration mode and the bed bar goes into what we call first order bending vibration, which means that where the bed bar is connected to the side plates are your pivot points, and the center of the bed bar is deflecting up and down. So
Okay.
it's like it's a single node bending. So it's just up and down, it's flexing, and the center is going high and low. And what happens is, obviously, as that starts to get into this vibration, it begins to increase the contact with the reel, and the reel starts to move as well. And so you get excessively high contact pressures between the reel and the bed knife. And of course, where the reel is the stiffest is where the spiders are connected to the shaft.
Yep.
And so what it does is the stiff part of the reel where those blades are erodes the material out of the bed knife, and you get this scalloped look of the bed knife. And if you look down the end of the bed knife, it looks like it's a rifling mark you would see in a barrel.
Mm-hmm.
And that's why it's called rifling.
Okay, that's awesome. That was a great explanation. I love it.
So, up to the point of the 3200 cutting unit, we had always had difficulty maintaining stability. And part of that, of course, is that the Toro methodology is that we recommend running light contact. And we expect those reels to run in light contact. And when we completed the 3200 cutting unit, that unit was stable at all speeds and all contact, with the stiffer reel, the stiffer bed bar pivots, everything being a little bit heavier. I went through the design analysis of all the components on that to make sure that there was no component that had a natural frequency in the blade pass frequency. Let me explain that a little bit. What
Okay.
you have is based on the real RPM. So let's say the reel is running 2000 RPM and you have 11 blades. You have basically that unit is hitting the blades are hitting the bed knife at that point in time at 2000 times 11 is what, 22,000 cycles per minute.
Mm-hmm.
You divide that by 60, you end up with a frequency. That's called the blade pass frequency.
Okay.
That blade pass frequency changes by virtue of the number of blades. If it's 8 blades versus 11 blades, or 14 versus 11. And if the reel speed changes anywhere from 1200 RPM up to 2200 RPM. So all those things connect. It's all based on how many times the bed knife contacts the reel blade. And that's what your frequency is. That sets up a vibration mode in the structure. The frame, the reel, the bed bar, bed knife assembly, everything gets a vibration mode based on that frequency. So what I did is during the design of the cutting unit, we went through and calculated natural frequency of all the components, which would be the bearings, the shaft of the reel, the bed bar, cross section with the bed knife bolted and unbolted, even the adjuster spring for the SPA adjuster, to make sure that nothing had a natural frequency where it would want to vibrate or go into a vibration mode anywhere in the range from 1000 RPM to 2500 RPM with
Mm-hmm.
all the different reel blades.
Wow. That's a lot to
And
cover.
so, yeah, there was a lot to cover. There was a lot of, and that was prior to when we could do it on the computer. So that was all hand math. So it was a little ugly, but we got through it. And there's lots of pages of mathematics that I still have stored on that. But anyway, the reel ran extremely stable. I mean, all speeds, all contact, and we actually complete a rifling test at Toro. It's one of the parameters to make sure everything passes. And what we do is we will take a reel and bed knife, an actual cutting unit, and we will run it in contact and polish it until everything is a snug, perfect fit. The light contact is there, everything's straight, square in the world. We spend a little time, a couple of hours getting everything polished in. And then what we do is we run it several clicks past the normal contact. And we run
Can
it at
we
speed.
time out right there? And
Sure.
you tell me, what is normal contact
Okay.
for, yeah, a deep,
Yeah,
yeah, let's, since I know we're in history a little bit, but let's talk
sure.
about the DPA for just a minute and tell us what's a normal contact. What does Toro
Well,
like to see?
yeah, the adjuster right now on the greens mower for each click moves the end of the bed knife toward the reel by 7/10ths or 7/10,000ths of an inch,
Mm-hmm.
a little less than a thousandth of an inch, 0.0007.
Yep.
And what we have always, over the years, I've developed a touch and a feel and an ear for it. But that's, of course, that's my requirement, and it's difficult to explain that to someone else. So what we actually recommend is that we send with each new cutting unit, there's a piece of shim stock in there, and it's a 2000th piece of stainless steel shim. And what we recommend is that you bring the knife and the reel up to where you have just light drag, where as the reel blade goes over, it just catches and gives a very slight drag onto that piece of shim stock,
Hmm.
so that you're basically spacing it like you would with a feeler gauge.
Right.
At that point in time, we say 3 clicks. It's a 2000 shim. You bring it in 2001. Okay, you know what I mean?
Hmm.
And so what you should end up with is what we consider light contact, where you hear the reel blades just contacting the reel, or not the reel blades contacting, I'm sorry, reel
Oh,
blades
that's all right.
contacting the bed knife.
Hmm.
And yet you still have a very nice smooth flow. And as you pull on it, it doesn't tend to restrain or slow the reel to any significant amount. So we are talking light contact within less than half a thou for sure.
Okay. No, that's great. And I think that's really good information for a lot of people.
Okay,
And, one thing I learned from another gentleman, John Patterson, been in the industry a long time. And he's been doing this a long time, and I've been doing it a long time. And he's telling me that he uses a filler gauge to set his 2000s clearance. And then he was at PGA National, and they
sure.
had a tournament, and they had a bunch of Toro stuff. So Toro engineers were down there, and they told him just what you just told us, the 2000s and plus 3 clicks.
Yep,
And but the thing that really got to me was, as long as John's been doing this, and I look up to him, and
sure.
he even said, I thought I was as good as anybody just cutting paper. But when he started using a filler gauge, he realized he was off a little bit.
It can throw you off. The paper is different. There's a different feel here and there. The reality is, and the fortunate part of it is, and we're getting into the weeds a little bit on the details. But the cutting units now, the new DPAs and all these new cutting units are stable enough that if you're off a little, let's say you still use the paper and you go with that. And, I've heard, where you have two pieces of paper, and, or the paper is either in line with the knife or perpendicular to the knife. There's all kinds of different ways.
Mhm.
The reality is the cutting units are stable. They will mow fine at that point, and they will even mow with no contact. I know there are people that are prone to that as well, even though we prefer contact and recommend it. But I know it works for some people, and if the practice works for them, that's fine. It's just going to change overall anything that deviates from maybe, I don't want to use the term perfection or whatever, but that's not the point. If your adjustment is slightly off and it works for you, it just may change the required amount of maintenance than what you could get out of it. But it will run fine. And so that there's advantages to that from that standpoint, that there's stability there.
Okay. Yep. I mean, it makes perfect sense to me. Can you tell us what led to the DPA?
Well, going back to the history, right after we had done the 3200, the next project at Toro for me was the Flex Walk Greens mower. And we went in and did a design on that walker where we had obviously the flexible links connecting the reel, and the pitch arms connecting the reel to the tractor, allowing the tractor to flex or move relative to the cutting unit so that the cutting unit could follow the ground. That cutting unit design is really the basis for everything since then. And that was done in the late 90s, 98, 99. All the geometry in the flex cutting unit is what is exactly that geometry is in the DPA cutting unit right now.
Hmm.
The bed bar pivot locations, the roller locations, the adjuster points, everything was done on that particular cutting unit. And that was done specifically to make sure that the cutting unit was consistent over time. And we spent quite a bit of time going through, again, the stability with the tubular reel shaft. All the adjustments were stable. The dual point adjustment actually originally came from the old GR1000 Walk Greens mower.
Yep. Okay.
And we changed it a little bit in terms of the components, but the concept was carried from the GR1000, which was introduced in 89. And we brought that over to a standalone cutting unit for the Flex because we had seen the stability and the ability to get rid of the parallel adjustment of the bed bar to the reel. On an S, you always ended up having to go in and have one end of the bed bar had to be slidably adjustable up or down in order to ensure that you had the bed knife parallel to the reel.
Mm-hmm.
So one end was a pivot, the other end was adjusted up and down. In the case of the greens mowers, it had a cam that you would rotate, and that would allow you to rotate that point to get it up and down. Just a pain. I mean, let's be honest, it was a pain, right?
Yes, it was a pain.
And
I'll
it was
agree.
a pain. And so one of the things that we did on the Flex was to take the change in the approach. We had always used welded reel frames prior to that, where you had the center section and two side plates that you bolted on or welded on to the center section. When you welded those plates on, the steel plates, they would have a tendency to warp.
Yep.
And so flatness was an issue. And so one of the things we did on the 3200, carrying the same concept forward, is we spent a specific amount of time to get plates that were much flatter and stiffer than what we had previously on the old 4-bolt and the SPAs. That again helped the overall stability of the cutting unit. And we changed the bearings from the tapered roller bearings to the self-aligning ball bearings, again giving the reel more stability if things were not aligned.
Mm-hmm.
When we went to the Walker, we decided to go away from the weldment, and we had a bolt together cutting unit where the center section on the original Flex 21, instead of a casting like you see on the DPA, was an extrusion, an aluminum extrusion. And the two side plates that were fully machined before they were bolted on were bolted on, and they were keyed to the extrusion, so everything was aligned when you started. So that you didn't have to worry about the frame not being square.
Okay.
We also stayed with the ball bearings, but instead of a self-aligning ball bearing, we went to a standard deep groove ball bearing with a slightly increased clearance internally. There is, if you were to order or buy a deep groove ball bearing off the shelf, the normal clearance is what's called a CN, C normal. That's just the term that's used in the bearing industry.
Okay.
The clearance level that we used was a C3, which a C normal clearance on a deep groove ball bearing is somewhere around 3 to 5/10 clearance between the inner race, the balls, and the outer race. Total clearance in that bearing. In a C3 bearing, that's 8/10.
Okay.
So that's some difference. It's not a lot.
Mm-hmm.
The reason we did that was we knew even though we were bolting the frame together, there would still be some possible misalignment, and we did not want to pre-stress the bearings too high. Now, when we went through the initial testing of that particular cutting unit, we found that the deep groove ball bearing, we would have stability issues where the reel would want to move slightly because of the clearance in the ball bearings. Believe it or not, that 8/10 was more clearance than what we wanted. So what we did is we went in and we added a wave washer on one end.
Okay. Yep.
By adding the wave washer on one side plate, and the way it goes through is it loads the outside race to the inside race on the one bearing, through the reel shaft to the inside race, back to the outside race on the other bearing. So both bearings are slightly preloaded, which is what's done on all high-speed spindles in the world for these high-speed machining centers, et cetera, and so forth, that spin up to 10,000, 12,000 RPM. It's the same mechanism. What that does is that forces the balls to shift, and everything moves so it has a single path. So they're not wandering around inside seeking a rotating path. It puts everything online and everything rotates in a true circle. When we had the tapered roller bearings, because the welded frames were never stable, they were never as square as we wanted them to be, you would end up with the bearings running at an oval. They would be at a slight angle. So what you would end up with is with a tapered roller bearing, with the roller, you have one end of the roller is called the heel and the other end of the roller is called the toe. And it would transfer as it would go around, because it's not running in the true circle.
Mm-hmm.
It's running at a slight angle, that it would go from the toe to the heel, back to the toe, back to the heel, and it was running an oval instead of a circle. And that's why those cuttings were never as stable as we wanted them.
Ah, okay. Yeah. I mean, all
So,
this, is making a ton of sense. You're blowing my mind
yeah.
here. I love it. It's
So the
awesome.
ball bearing, so the ball bearing with the preload now allows you to run a true circle, and it preloads everything so it finds a single node. So what you do is you define the strength of the preload is high enough to take all the clearance out of the bearing, so that when you're done, you have a bearings setup that's even tighter than a CN, just because everything's preloaded and it follows a path.
Mm-hmm.
So there is no clearance in the system when you're done. It's very tight, very clean, and that's why they're stable. We've run those reels well over 2,500 RPM, and they're just as stable as you want. So there's no problems.
Wow.
And
It's awesome.
so that was one of the things that we learned. The other thing that we went through was, again, you had mentioned some interest in how we got to the bed bar pivot, and the bed bar pivot, obviously, the issue that we had seen with the older cutting units where the bed bar pivot was twofold. One, the bed bar pivot was low and had a tendency, as the reel would wear, that you would adjust the bed knife up to the reel and you would start to get contact of the rear of the bed bar down in the grass. So it would be riding on that bed bar.
Mm-hmm.
In fact, a GR1000 gets part of its support from the bed bar. And so the problem with the GR1000 was that when you were mowing and you had a worn reel, you were never sure what height of cut you were getting, because the bed bar was riding into the grass.
Mm-hmm.
So it affected things. So one of the things that we wanted to do was to get the bed bar pivot up out of the grass, to make sure that the bed bar was never a support structure and never something that you couldn't quantify. The other item is, we were looking ahead for this cutting unit in other usages, but what we wanted to ensure that if you had a mixed fleet, and in the case of using it on a triplex, if you had different levels of grind, so the reel was a different diameter, they needed to cut the same.
Mm-hmm.
We had learned during the 3200 development that the behind center distance, the point where the bed knife contacts the reel, is a huge contributor to how aggressive the cutting unit is, the cleanliness of cut, the amount of marking. We spent months and countless hours in the grass with those cutting units in order to learn all these things, where we could change one thing and predict what it was going to do. Once we had gotten to the point of predictability, then we felt we were ready to design. So at that point, we wanted to make sure that the cutting unit was stable over its life. And so we wanted that behind center distance to remain unchanged at a set height of cut, regardless of the diameter of the reel. And what that means is, if I'm mowing at 1/8 of an inch, and I have one unit that has a reel that is brand new at 5 inches, and one that is almost worn out at 4.5 inches, that behind center distance needs to be the same, so they cut the same.
Mm-hmm.
Historically, what happened is that as the reel wore, that distance would actually grow and the unit would become more aggressive. And so it would now have a completely different look in the grass, because it was cutting more aggressively. It was leaving less stragglers. It was actually cutting a little lower here and there. It was doing all kinds of things differently, and it would look entirely different. And that was where part of the issue that I remember talking to people with triplexes, that if they went out and mowed with their old triplex on a green and they hit something, they had to pull that reel to grind. They would grind all three to make sure that they all matched. Otherwise, it would look different.
Yep.
And so with the bed bar pivot, now at a point where it is higher to one, get that bed bar up out of the grass, and rather than just pivot the bed knife upward, it also pushes the bed knife forward. Because what happens is you do the adjustment on the front roller, that tips the cutting unit forward. So the reel tends to move forward. It's going to pivot around the rear roller. Sorry, I'm getting into the weeds here.
Oh no, I love it,
apologize.
man. This is right up my alley. I love it.
So it pivots around the rear roller, and as you would lower the adjustment, because the reel is wearing to maintain that eighth of an inch, let's say, that reel moves forward. It pivots forward. Well, the bed bar, as you're adjusting it, if it moves just upward, it's not keeping pace with it. So we actually have it so it swings forward, so that regardless, like I said, whether it's 5.06 brand new or 4.56 worn out, that behind center distance is the same within one thousandth of an inch.
Wow, that's incredible. That's impressive.
So that maintains stability of that cutting unit. The aftercut appearance stays the same. Everything stays the same throughout the life of the reel. So it's clean. And again, that was initially designed into the Flex 21 cutting unit. At a later point in time, there was a project to look at a design of a new cutting unit for the triplex. And I did not have that particular product directly, but I knew the designer that was working on that and recommended to him that he take a look at the cutting unit on the Flex 21 as a possible answer for that, because I told him that all the geometry was there. And he had been spending months looking at all different things and trying different things and couldn't get it to work. And he put a set of flex cutting units on the machine, and they were perfect. They worked right out of the box.
That's
So
awesome.
the DPA then, when it was first designed, the reality is the change between the DPA and the flex was, we used to give him the designer on that project a little grief in that he changed 7 parts. Instead of the extrusion on the back, he went to a casting. And instead of sand castings on the side plates, he went to die castings. And so, I mean, the reality was there was very few changes in terms of the actual cutting unit. Certainly no changes in geometry, but different changes in terms of manufacturing because of the higher volume of the cutting unit. And therefore, he did improvements on that, because the processes that he picked were more stable than what we were using, because he could afford to go to the higher cost processing.
Okay, yeah, that makes sense. So when did the Edge series come around, and what led to that?
Well, the Edge series, we were getting feedback from customers that we weren't getting the edge retention that they were seeing from some of the competition. We were hearing some things, and obviously Baroness was pushing the main part of that boat at this point. They were doing a number of things. Of course, a Baroness bed knife was fully machined all the way around and was a huge amount of money. But on the other hand, it held an edge extremely well. We had one of the tests that we do there is we also do a destruction test, where we will be spinning the reel, and we will stick a 3/4 inch diameter steel shaft up into the reel while it's spinning.
Wow.
And our intent is that nothing comes off, nothing gets broken. And so we always had safe cutting units. The fact is, we were, doing some things with some of the materials for the European market on the heavier reels. We were using lost tempered knives, so that you could literally go in and you could hammer them back into shape, because they were using those large reels for cutting road ditches.
Oh,
And
okay.
they always used to talk about anecdotally that they would run into a bicycle frame because someone had lost a bicycle somewhere
Mm-hmm.
and they didn't want anything broken. And so it was a big push on our part to make sure nothing would break. Well, when you do that, hardness begins to suffer at that point. You go to more ductility than hardness. And we were getting to the point where, yeah, everything held up really well. And when you put a Baroness reel on our stands, you would have shrapnel come out and, reel blades would break and bed knives would break. And it was our feeling that somewhere there should be an answer in between. And we knew, and the gentleman who was working on that is still working at Toro, is Scott Coffin. So if you see Scott sometime at the golf show, say hey,
Okay, I definitely will.
But he was spearheading that at this point. He was working on fairway reels while I had greensboro reels, and of course, he was getting a lot of feedback on the fairway reels where they were not lasting, long enough, and less so to the greensbores, but still an issue there as well. And so he started working diligently on trying to come up with different materials and different, some of the knives were big enough that you could put an insert into them instead of having the whole knife, that heavier duty material. And there's a tremendous amount of testing done at Toro for wear, where we developed a test where we would actually run these different knives against an abrasive panels, and we were checking that. And then we also have an impact test where we had qualified it rather than having to build up a reel and run it and insert a stake. Calculations were done on what you needed, and we had a drop hammer test where you would bolt a bed knife in and you would put a drop hammer on it, and you would, and you would check all your materials. And so I'd be willing to bet that the design team with Scott probably looked at hundreds of materials.
Mm-hmm.
And until he'd gotten to the point where we are today with the material that seems to be, from a durability point, seems to hold up to most impacts. You can still lose a piece now and then, but that's kind of the trade-off for the extended wear and not having to grind as often or replace as often.
No, I mean, it's great. And my personal experience with it, I love the Edge series. I think it's the best thing out there. I hadn't tried the Baroness, to be fair, but versus the other competition,
Sure.
it's night and day different.
Yeah, yeah, and I know there's a number of companies. I forget the name of a company that does a lot of bed knives. They're pretty big into it, and they were pretty solid competition there for a while, but we've managed to move past them as well. So we're fortunate. We've always been fortunate in that the Toro management group has done the right decisions. In that they go in, and even if times get hard or whatever, they never cut back on their engineering budget.
Well,
The
that's
teams,
something I don't know, I hadn't been on your side of the fence, but what I see from the other manufacturers, your competition, or Toro's competition, I don't see them putting a lot of R&D and engineering into, I mean, cutting units, and that's kind of our bread and butter.
right,
You know,
right.
I mean, at the end of the day, that's what we're doing. We're trying to mow grass.
Well, yeah, and the thing is, at this point, the cutting units group and the greens mower and fairway group. There's three groups that are involved. Cutting units are mostly folded under greens mowers, but there is a group that does fairways as well. But there are teams, complete teams that are involved with all this stuff, and there's this constant work on what can be improved, what can be made better. Something as simple as the old grass shields used to be galvanneal material, which would rust and cause problems and this sort of thing. Now it's stainless. I mean, as
Mhm.
as small of an item as that is, it's still a major item long term in the durability of the cutting unit. In that, I remember seeing cutting units, the older cutting units, where the grass shields were rusted through and this sort of thing because people didn't clean them, whatever. That's life. That's the way people are. There's different variations on how people handle things. The new
Mhm.
grass shields, you don't hear that. You don't see that. So even little things like that make the difference long term. Stainless steel bearings, stainless steel this, all the castings are stainless steel now on the height of cut adjusters, the groomers, all that sort of thing. That long-term durability is a big issue for us, and we're always looking for a way to try and do an improvement. And we're not 100%, but we keep trying. So
Yeah, and I mean everything that I don't know. I'm a big Toro fan, and I own quite a bit, or I work on quite a bit of John Deere, and it's a fine product. Can it mow grass? Yes, but if it was left up to me, I would be buying a Toro
yeah,
any
I
day of the
find,
week.
I worked with John Deere equipment, and they have some neat concepts and some neat things, and I know a lot of those guys that designed that equipment, and a good group of people. But I think when you get to the bottom line, I hope we do a better job than they do. Our adjustments are more convenient, they're more stable. The overall geometry is just cleaner and better, just because I think we have a longer history with it. And, we have people, not unlike myself, that have been with cutting units for 30 years. And so we understand how all that stuff works. So
Yeah, I mean that has to make a huge difference in having a group with a long tenure that's been in cutting units. What I love about Task Tracker is they're constantly innovating and listening to their users. They've added dozens of updates to make our job easier. One new feature is the ability to upload manuals to the equipment. All you have to do is scan the equipment QR code and you have the manual and all other information at the tip of your fingers. You can even create links to those manuals in the work orders, and it goes directly to the page that you need. Make your life a lot easier and check them out at asbtasktracker.com. Let's get back to the episode. Let me ask you another question on, we won't get too far away from cutting units. How about bed knives? So I know Toro has an extended bed knife, and I just found out last week that you have a short bed knife.
yes, sir. Yes, we do. Well, part of that was specifically, the last project that I worked on was the new walk greens mowers. And one of the things that we wanted to do, I know there was a time period where we were offering different bed bars for the greens mowers. And my response to that was, it's just from the standpoint of, you're trying to identify the bed bars. Some they're supposed to be painted red, they're supposed to be painted black. And honestly, that whole concept initiated with the GR1000. Back in the late 80s, early 90s, there was a standard bed bar and what they called a deep penetration bed bar, which took the bottom of the bed bar and moved it up so it wasn't a support structure in the grass. Well, that particular machine, because of its length and its weight and this sort of thing, it made a huge difference. I
Hmm.
mean, it would change the height of cut by at least 15, if not 20, 25 thousandths. I mean, it was
Wow.
dramatic. I mean, it was dangerous is what it was. And if actually, if you were if you were mowing at, 140 and you put this deep penetration bed bar on there, it got yellow in a hurry. I mean, it
Oh,
was just
yeah.
it was ugly. And so when the original Flex came out, the original Flex was actually set up aggressive as a relatively aggressive mower, and it was actually did an excellent job there. But some people were concerned. There was one customer that had come back with feedback that he'd had a rainy session for 3 weeks, and all of a sudden he was showing some marking on the greens, and there was a group that was handling the walkers at that time. I was not. I was working on a different product. They decided to go back to a what we called a standard behind center distance. So they made it less aggressive.
Can you elaborate on what the standard behind center distance is?
Well, the old statement, how do I want to say this? They always used to talk about height of cut and behind center distances. There's some relationships there and that sort of thing. I guess I can't give you a hard, fast number. I would tell you you could certainly measure it off of a cutting unit if you wanted to. But what we really try to control is how far the reel will rotate below the bed knife into the grass as it's trying to pull the grass in.
Okay.
So if you look from the side of the cutting unit, if you were to do a section and you looked at where you had the unit sitting on a surface plate or on the grass or whatever, and you'd see where the knife is behind center. So that means that the reel is actually slightly lower than where you're cutting the grass as it
Yes.
swings through. It goes through that arc.
Mm-hmm.
If that arc becomes too large, obviously the unit becomes too aggressive. If that arc is too small, the unit does not cut well.
Mm-hmm.
And so what we found was that people were playing with that to some degree, and the thought process was to give them specific components. And that's where the bed bars were supposed to give them those different points, where if you had a condition where it was giving you marking because it appeared to be too aggressive, you could go to this different bed bar. Well, the reality is it was my impression that doing the bed knife was a cleaner fix than doing the bed bar. That way you could have an assembly up on the shelf with a bed bar and a bed knife. You could drop it out, drop it back in. You could have that change done in just virtually no time instead of trying to do a whole bed bar, et cetera, and so forth. It just,
Mm-hmm.
and the ability, obviously to have the extended knife, which was actually a request from, believe it or not, the Swedish in the 90s. They were seeing issues up there close to the Arctic Circle where the grass was not growing well, that they needed a knife that was like not aggressive at all. They needed a unit that would cut not aggressive. And of course, that was at the time with the GR1000. So there was an extended knife that was requested by them in order to resolve that issue.
Okay.
That particular knife was carried along, and that concept has been carried along specifically in walkers for years then. So that extended knife. And then we went in and we did a shorter knife then at this point in those conditions where you want to be quite aggressive. Part of the design of the last Walk Greens mower was to make that a worldwide machine. What we found was that the walkers that we were offering, such as the GR1000 for the fixed head walker, was not very popular in the Far East because it was not aggressive enough. It did not cut the way they wanted, and they were just unhappy with the overall machine. It did not fit their mindset of what a machine should be.
Mm-hmm.
So we went in and we did the design. And of course, we were looking at the GR1000 as getting dated because it was a heavy machine. It handled heavy. It was obviously that particular cutting unit was when it was designed, it was optimized around a height of cut of 0.156. Obviously, that height of cut is not realistic anymore,
Right.
especially for a walker. When we did the Flex 21 in the late 90s, we optimized that around 100. And so the new walkers are optimized at 100 or even lower. So, I mean, they were built so that you could cut low with them. But the issue was, and of course it was made so it handled lighter, it felt lighter, it moved easier, this sort of thing. But there was still that concern from the Far East that they wanted to be able to be very aggressive. And the reason for that is their practices are slightly different. Greens, for the most part, are relatively flat. They are very hard, and they use a kikuyu grass or some other form of that, which is a very abrasive, very difficult grass to cut. So they tend to run very aggressive. So the behind center distance that they run on a Baroness in Japan is like 400 thousandths.
Wow. Okay. That's
It
way
is
back
big.
there.
It is way back there. So what you look at here in the walkers right now, and the walkers are set up that with the 3 different knives, and you've got the 2 drum positions on the fixed walker. I don't know if you're familiar with the new walker or not,
No,
where the
I
drum.
hadn't experienced the new Walker. So it has
Okay,
two drum positions?
that's correct. Yes,
Okay.
so you can put the drum in the forward position for lower heights of cut, and with a standard knife and a standard drum position, your behind center distance at an eighth of an inch is somewhere. It's in that range. It's somewhere. God, it's going to be 150, somewhere in that range. I don't remember, obviously, Trent,
Oh, no worries,
and
no worries.
I'm not going to give you a hard number on that anyway as to what that is, but it's, it's something you could measure. But I do know that the one that is set up, that for these Asian markets, you can move the drum in the opposite position, put a short bed knife in there, and your behind center distance is 375 to 400.
Wow, okay.
So you can configure that machine, and if you put an extended knife on there, the behind center distance with the drum in one position is almost zero. So
Mhm.
you can go from 0 to 400 behind center distance on that machine at the same height of cut.
Wow.
And so it allows you to get any range of what you need to do in order to get that grass cut at this point. The other thing that the walker does with that second drum position is you can rotate to the second drum position, raise your height to cut to 7/8 of an inch, put a short knife on it, and it cuts very effectively, because your behind center distance now is back where it should be, and you've lifted that whole machine up so that you're cutting that well above a half an inch to 7/8 of an inch very effectively. Whereas with the other walkers, as you keep racking them back, you can't move the rear drum, and you just keep moving that upper height to cut. The unit's leaning way back, and the knife goes forward, and your behind center distance is not very efficient, and you have a tendency to flail at the grass rather than the wood. So,
Mhm. Yeah, I talked to a friend the other day, and he was they were trying to mow tees at whatever, 800 or something
right,
with a
right.
1000, and, it was not working, and I guess, do y'all sell a kit or something too? I think he said something about clip kit.
Well, the clip kit has a tendency, all the clip kit does is slow the reel down. And so it doesn't really change that. The behind center distance is where the real issue comes in terms of how efficiently it cuts as well. So
Mm,
it will cut, but not very well at those high heights. So,
gotcha. So what do you call when the reel dips below the bed knife into the turf? What do you call that?
oh, I don't know if there's a real term for that.
Well,
Um,
I've heard others call it dip, which kind of makes
yeah,
sense, but I didn't
we
know if there was an industry term.
no, there's no industry term. I did a presentation. I've done it for a few people, and I demonstrate that that's a calculated number. In fact, I've got a spreadsheet that you can plug in basically the behind center distance that you have, the diameter of the reel, and it will automatically calculate for that distance that it goes below that point. And we really, I guess you can call it whatever you like, but there's no specific term for it.
Okay,
So,
yeah, all right, good enough. I was just curious
yep,
if
yep.
there was something out there or not that I hadn't heard about. Can you got How you doing on time?
I'm doing okay. Yeah, I don't even know what time it is. I don't have
It,
a clock in front
I
of me.
don't. We've
So,
been going almost an hour, so.
okay,
But I do have a couple more questions, I
sure.
think. So the next thing is bed knife attitude. So this is something recently that I've been, yeah, looking at a lot, and it doesn't really match up to what I learned in the book that bed
Well,
knife attitude is.
I'll tell you what attitude is. Attitude is a misnomer. It's not even a term that in my mind should be used. I don't care what the angle of the bed knife is. It doesn't matter. It makes absolutely no difference to the performance. It's the behind center distance that makes the difference.
That's what I mean. I'm with you, and
Yep.
it
So
makes
so
sense. But I
yep, the
definitely
behind.
think a lot of people have been taught the wrong way over the years.
Well, and the reason it was taught that way is that it had some semblance of fact, in that when you wanted to make a unit more aggressive, and both the rear roller and the front roller were adjustable, right? You would
Mm-hmm.
lower the rear roller, you would, push the rear of the cutting unit up and put the front of the cutting unit down, and you can make the unit more aggressive. And what that would do is it would put the cutting unit at a steeper angle. And so people would call that an attitude, but I'd put it at an angle. It's, and
Mm-hmm.
it's got an attitude at this point. Well, all they were doing in essence is they were swinging that reel forward, pulling that cutoff point between where the knife contacts the reel. They're pulling it rear back further so that the behind center distance got larger. And so the reality is that that unsupported reel where it goes below that point, or that cutoff point, got larger. The reel went deeper into the grass. The deeper it goes into the grass, the more it pulls up. And if the grass is in good shape, it can handle it. If it's not in good shape, it does not handle it. And so everyone got stuck on attitude because that was kind of the general vernacular. And because the bed knife and the bed bar didn't work together, now with the new cutting unit, the DPA, that point stays the same whether the reel is worn or not. So it doesn't change the attitude of the cutting unit, even though the cutting unit is leaning more and more because you're adjusting it down because the reel is getting smaller. The fact of the matter is, on a DPA cutting unit, when you start with a brand new cutting unit, the angle of the bed bar to the grass and again, use an eighth of an inch height to cut,
Mm-hmm.
is about 7 degrees. It's 7 degrees. The back is higher than the front. When that reel is, 9 degrees, and when it's fully worn out, it's 7 degrees. It doesn't change because of what we do, the way we change it. Now, you could take a GR1000 and that angle would change from like 1 or 2 degrees to 7 or 8 degrees. It would go the opposite direction.
Mm-hmm.
But the GR1000, as the reel got smaller, got much more aggressive. But the angle was actually going the wrong way. And so it's that attitude or angle of the bed bar. People have a tendency to measure that because it's easy to measure, but it really doesn't mean anything. It's that behind center distance that's key. Now, we actually built some tools for that. If you were to take the old Hytha cut bed bars where they have the adjusting screw in there,
Mm-hmm.
if you take a piece of angle iron, a thin piece of angle iron that can reach up to the reel center line, and you bolt that on there. Now you put that up to the roller, slide it up through that piece of the leg of the angle iron up through the reel blades, and slide it back until it contacts the face of the reel shaft.
Mm-hmm.
On the latest DPA cutting units, there are areas of that reel shaft that are machined. And
Yes.
so you touch those particular areas, and where that comes down, you measure that distance from that angle iron to the front of your knife. And then you calculate the radius of the reel shaft, and you know what your behind center distance is at that point.
Gotcha. So yeah, can you tell us what the rate or the diameter of the shaft is?
I don't remember that, Trent.
Okay.
Honestly, I don't remember that.
No worries. I was thinking, I thought that shaft was like inch and 3/8, but where
Yeah,
the datums are, I think it's maybe 20 thousandths smaller or something like that.
I don't remember what that is. I know Mr. Coffin would know that, and if you contact Jeff, he could get through to Mr. Coffin and get you that number.
Yeah, and I don't know if that's something they want out in the public or not.
Well, yeah, and I don't know. I don't know if it's. I don't think that's necessarily a specific detail. It's that secretive. It's a turn diameter that is something that is put in there specifically. So not only can you measure the behind center distance accurately, you can measure to make sure that the reel isn't cone shaped from that particular area by simply dropping a callip, right
Mhm.
through there and measuring that and make sure that you don't have a reel that's cone shaped. I know some people like to use the pie tape or whatever, but that's another methodology that's there, and it was put in there specifically for that, so people could go in and do analysis on their own.
Okay.
I,
So it
I
wouldn't, I kind of assume maybe it was for Foley since they gauge off the shaft.
well, I think there's part of that there. But,
Mm-hmm.
you know, once you have the datum there, there's all kinds of things you can do with it, right? And so going in with a caliper is a very quick way to measure them and say, "Hey, this is what we got, and this is where we're at," you know? So it gives you some quick numbers there. And, yeah, some people will use it to gauge off of when they go to do a spin grind or whatever. So the datum's there. It's good for any information. You know, I'm a firm believer that every shop should have a granite surface plate in it. And in order to go in and check the parallelism of the reel to the rollers and another methodology there of checking the cone shape to the reel, all those things are critical to me. And a granite surface plate's a few $100 and it beats the aluminum plates. Or as some people I seen, they say, well, gee, there's a steel flat on their grinder and they put it on that. I have no idea what that is. A
Mm-hmm.
cheap granite surface plate is flat within tenths, you know what I mean?
Yeah,
And
yeah,
it just
yeah.
and it's such a slick way to measure things then at that point.
Oh, I agree. And so I'll tell you my story. Found, and it was a Starrett pink granite, and it's 4 by 3,
Yeah.
and I found it on Facebook Marketplace for $600.
Isn't that amazing?
Yeah,
I
600,
mean,
6 inches thick,
yeah,
weighs a
I mean,
thousand pounds.
it's just one of those things that once you get it in the shop, you're using it all the time because it's easy to measure off of and it's easy to gauge from and you know when you put something on there, you know, between a chunk of granite, and it wouldn't have to be that big, right?
Hmm.
I mean, you know, it's just got to be longer than the widest cutting unit you're working on. And that and a piece of bar stock that's ground that you can slide under the reel up against the face of the bed knife, and you can check parallelism of front rear rollers right now. I mean, it's with a sheet of paper, you know, or you can even just look at it. So,
Right, right, right. Yeah. So what about, I know Toro sells an eccentric kit for the rear roller. What
yes,
do you think that should be standard?
no,
No.
I've never seen the need for it standard. Every
Okay.
time I've ever put one of those cutting units on a surface plate, uh, we always check it with a sheet of paper, which is less than 3 thou. And
Hmm.
I've never had one be able to slide under a roller yet. It's just I if there are some out there that need it, I'm surprised. If they are very few, and you know, there are some people who get wrapped up and say, "Well, it's not zero." Okay, I get that. But you know, how round is round? You know, at what point do you stop? And you know, some people are getting into the habit where they're turning the rollers because the run out in the roller is 10 or 15 thousandths and they want it to be zero. Y- you know, that's all well and good. And I understand your concerns, but the reality is we are working with grass. We're working with a surface that is not flat. And, the way those particular dimensions are projected out over the length of the circumference of the roller or any of those things, the eye can never see it.
Right. No, I'm with you there. Yeah, and I do think people get in that too deep in that rabbit hole sometimes on
Right,
trying to make
right.
everything perfect to take it out to a fairway or a green that's not perfect.
Well, and the other thing is, you know, this is this always surprises people when you do the math, but you know, there's that old statement that says that the clip should be equivalent to the height of cut. Well, you know, that's not I've never found that to be true, but that was always the old numbers, right?
Mhm.
And if you run and just draw a triangle, okay? Let's say you have a cutting unit that is set at an eighth of an inch height of cut, and your clip is an eighth of an inch. So now you are going to have a triangle that is basically an eighth of an inch on the bottom and an eighth of an inch high in the center. Draw a triangle.
Okay.
So you draw a line straight down the center of that. Okay. So you end up with a right triangle that is 60 thousandths on one side and an eighth of an inch on the other. Now, The bed knife pushes the grass forward. The reel pulls the grass rearward. The shortest grass is going to be right where the knife was and the reel contact.
Mm-hmm.
The longest grass is going to be the hypotenuse of that triangle where the knife pushed it forward or the reel blade pushed it back. Okay, so
Yep.
you end up with a triangle that says it's 125 at the shortest blade of grass. It moved 062, and the hypotenuse of that is 17 thousandths longer than 125.
Okay.
So that
Did you
means
just do that math on in your head or on paper?
I've done it on paper enough that
Okay.
I remember the number.
Okay.
Okay.
All right.
But the reality is that grass is cut as a scallop, and between each cut is 17 thousandths variation. Okay.
Mm-hmm.
So, and the only reason your eye doesn't see that is because of the helix and it blends out all over. Okay. So your eye cannot see 17 thousandths over that distance. If you have a roller that has 20 thousandths run out, that means it's plus or minus 10 over the circumference of the roller, which at a 2.5-inch roller is what, 6 or 7 inches?
Mm-hmm.
What's the possibility you seeing 20 thousandths over 7 inches when you can't see 17 over 1 inch?
Well, right. Yeah. No, I mean, that's a great point, and I'm so glad you said that. And I hope anybody that's listening really lets that soak in.
The reality is, and I understand that, you know, obviously you don't want rollers that are all round, you don't want reels that are all round. I get that. And I'll be the first to support that. But there's a reason that we give you the numbers that we do. Toro has gone through and spent a lot of years designing those things. And if you're within our print specifications, you're going to get very effective performance.
Mm-hmm.
And to come back and say, oh, I just don't think that's good enough. Well, maybe for you it's not, but I think you're going to struggle to see where it's any improvement in the grass. So
Right. No, I'm with you. Yeah, you can throw dollars at pennies if you want to.
that's the
You know.
truth. And I know some people. Now, does that say that we have all the answers? No, I wouldn't even attempt to say that.
Oh well,
But we
no.
do
Yeah.
but we do have a lot of years in the grass, and we spend a lot of time with it. And we are probably as close as just about anybody on getting things where they need to be. Can there be improvements made? Absolutely. And some people may have conditions that they've made improvements by doing things. And I go, cool, good for you. Wouldn't have been my first response, but I'll be honest with you, 9 times out of 10, when I go out to look at a quality of cut issue, the first thing I do to diagnose what's going on is I put the machine back to stock. Yeah, all the adjustments and everything back to what we recommend as it comes out of the box.
Mm-hmm.
Now, when you go out and mow, you can look at that grass, and because of the years that I've had experience, and anybody that's done that can look at it and say, okay, if I make this change, I know what it's going to do. I get there and there's been 7 things done. I don't know what any of those are going to do. So I start at stock. And boy, a lot of times that's all it needs is it goes back to stock and it looks really good. So,
Well, and yeah, have you ever seen where maybe a customer makes 4 changes because they were having a problem instead of just 1?
oh yeah,
You know,
that happens
just
all the time. Yeah,
yeah.
where the people they say, well, let's do this and this and this and this and see what it does, and you really don't know what any of those are going to do. Whereas you have to kind of approach it one step at a time. And I was at a particular customer that had some issues. We put everything back to stock. They had changed knives. They changed this. They changed that. They changed all kinds of things. And what we finally found out was going out, his turf conditions were a little bit sensitive, and we went from a Wiley roller to a full roller with everything else stock, and it looked perfect. So it's just a matter sometimes of understanding where you are. So,
Yep. No, that's really, really good stuff. Can I ask you maybe some fun questions?
oh, okay, I guess.
So, Is it true that most brilliant engineers use pencil and paper instead of computers?
Well, I would say there's a combination of what gets done. Honestly, not that I put myself into that particular class, but I like to run things on pencil and paper and then do it on the computer and see if the numbers come out at least similar.
Okay. Yeah, yeah. No, it
I
makes
I
total sense.
I don't like to just expect the computer to give me an answer and just take that answer for granted that without understanding the problem. So I have a tendency to do some significant mathematics by hand and then say, hey, I should be in the ballpark. There are some things, for instance, you cannot do cleanly on a piece of paper. I talked about doing the natural frequency of all the components. Now, that took me weeks to do that. Now you can do that on the computer. You know what I mean? But you should at least have an idea. But I look at it a lot of times in terms of strength of components, where I'll run a beam calculation, strength of the beam or whatever, where I'll put a simplified section in there where I make it like a rectangle or a circle or whatever, and run a quick number and say, hey, I'm putting this many pounds on the end of that shaft. Is it going to bend or is it not going to bend, or is the stress too high, or is the bearing stress too high, or whatever? And I have those numbers in my head, and then we go over and we do the actual computer work and we run the FEA analysis, and the FEA analysis usually agrees with what I have. And I go, yep, I feel good about that then. I've got that in my head.
Right, right. No,
Now,
that makes sense.
and of course that's really prevalent, more prevalent, I would say, for people that are doing more new product design. If you're doing more stuff where you're doing product support of material that's out there, maybe less so of that is required because you're working on a problem that you've got a known set of parameters on, as opposed to extending the technology. So for me to tell you that the good engineers use only pencils, I can't say that. I think the conditions are, it depends on the set of circumstances that they're in, and it depends on the person. I'm old school. I've done this for a lot of years, and when I started, the technology was we had just retired the slide rules and we're using electronic calculators, and the CAD systems were so expensive that there were more people to run them than there were available. So they had to do it on a timeshare basis.
Hmm.
And and the technology to transfer information from one person to another electronically was by fax machine. So you basically, off of that, you learn how to run dividers and compasses and circle templates and sketches. So that's kind of what I grew up with. So
No, and so one reason I asked that question, when I saw you at the show in Phoenix and I asked a question, you pulled out your notepad and your pen.
yes, yes.
So,
Well,
and I loved it. I mean, I think it's
yeah,
awesome.
my notepad is still, when the big one hits, it's still going to be functional at that point. So as long as I am functional, it is. So
I got you. Yeah. Well, and I have a really good friend. He's, I don't know, mid 70s, I guess. And he's the same way. He has his notepad in his shirt pocket and a pencil, no matter where he goes or what he does. As soon as he gets out of bed and puts his shirt on, that's going in his pocket. So, what was the other one? Do you know who said to invent, you must need a good imagination and a pile of junk?
no, I'm not aware of who made that statement.
I'm not either. So, that was one of the questions I had that
I, I, I
somebody
do,
sent me.
I do know that what was his name? God, I'm losing my mind here now. Invented the light bulb.
Edison?
He made the comment that most people miss opportunities because it looks like hard work. You know what I mean? So just so there's some statements there that he made which are kind of interesting. So
Well, you got the answer correct. I just looked it up. It's Thomas Edison.
okay,
Is the one that said that. So,
all
very
right.
good. Very good. Got it by default. What about some rapid fire questions? This is kind of the fun part.
Okay.
Yeah. What's your favorite movie?
Oh, wow. I suppose To Kill a Mockingbird.
Ah, great. Yeah. What would be your last meal?
Oh, probably grilled cheese sandwiches and tomato soup. So,
Oh, man. Yes, I love it. That's good. What are you most proud of?
oh, wow. Well, obviously, that's a pretty all-encompassing question, and I don't mean to dither, but you got your family and your accomplishments over the years. I've got pushing 30 patents, which worked with a good group of people. But I think probably the most things that I'm proud of is over all the years of working on cutting unit suspensions and different peoples and different groups and all this sort of thing, is that a lot of people I worked with have always said that I was the best person they ever worked with. So,
Oh, that is awesome. Yeah. How great is that? And how rewarding is that to hear from your colleagues? I would think that's pretty great to hear.
well, yeah, it certainly makes you pleased that you hit that point, and it's not something that you were trying to do. It just comes by virtue of the way it is. So that
Gotcha.
was good.
No, that's awesome. So out of 30 patents, do you have a favorite?
Oh gosh, I don't know. There's so many. None of those patents come alone. You know what I mean? It's not
Yeah, yeah, yeah.
me
Right, right.
alone. There's a group involved, and you look back at all the work that was done through the group. All the people that were involved and all the people that brought pieces to it. And I was fortunate enough to be there at the time and be party to that and help when I could. And so those things were all great. And I would say probably some of the most technical stuff that people don't realize is the triflex suspension. There's so many aspects to that there's so much detail to that in terms of how we push the cutting unit and the angles and the lift and the changes here and there. And so maybe that's the most satisfying to some degree, I guess. But just by virtue of the technical aspect of it, I guess I beyond that, I don't know if I could say there's a favorite on any of
Gotcha. No, I mean that. Yeah, it makes totally sense. Makes a lot of sense. And the Triflex is truly amazing. And I remember Helmut coming out to a local course and kind of doing a presentation on it, inside. And then we went outside and looked at it right after it come out. And I remember the geometry and how everything goes down to a V basically in the center of the cutting unit. And I thought
Yeah,
that was just amazing.
yeah, there's all kinds of things that you do to try and not to put an external force on a cutting unit that's not required. I mean, and that affects it in the graphs. And so you try to push close to the CG of the cutting unit. You're trying to allow the cutting unit to move freely. You lift on the outside edge when you make a turn so that it compensates for the tendency to push the cutting unit over as you're doing that turn. There's so many details, the caster angle at 7 degrees and all those things that are added in there that make that stuff work. So it was one of those things where we were kind of allowed to do what we felt was the best optimization for that suspension for that usage. And we went in and we kind of did what we felt was the right thing. And I think the results kind of show themselves. So
Yeah, I've not heard anybody complain with anything really on the Triflex. I think it's a really great unit, solid unit. Well, I think I've taken up enough of your time, and I really appreciate you talking to us and going so in depth on cutting units. We might have got in the weeds. Some people might turn us off, but that's okay. It really is good. It was super interesting to me and other nerds in the cutting unit world. I think will really, really enjoy this. So I can't thank you enough, Jerry. I really appreciate you coming on.
well, I appreciate the opportunity, Trent. It's not, I mean, it's not one of those things where, now that I'm out of the industry, if you will, per se, it's kind of like, who wants to talk to that codger? You know what I mean? So it was fun. There's a lot of people that I owe my success to, both that are currently still at Toro or that retired from Toro. And And I can't minimize that because we all build off of what comes in front of us. So
Very well said. Thank you so much for listening to the Real Turf Techs podcast. I hope you learned something today. Don't forget to subscribe. If you have any topics you would like to discuss or you'd like to be a guest, find us on Twitter at Real Turf Techs. See you, bye.